On behalf of the Center for Occupational and Environmental Health, I would like to welcome you to our webinar, Process Safety Implementation Pyramid, presented by Rich Meier. A few housekeeping items first. You'll be muted during this presentation. If you would like to ask a question, please enter it into the online chat or Q&A bar. We will save time at the end of this presentation to address questions. This webinar will also be available on YouTube following the presentation, and you will receive a link via email. At this time, I'm pleased to welcome our presenter, Rich Meier. Rich Meier served for 34 years as an OSHA compliance industrial hygienist. He was a senior IH in Nevada, a designated OSHA catastrophic event team, and Petro SEP team leader in the chemical process industries. Career highlights include leading the investigative team for the 1988 PEMCON rocket fuel plant explosion, the 1990 Pioneer chlor-alkali plant 100-ton chlorine release, and the 30-ton Sierra Chemical dynamite plant explosion, among other large events. Mr. Meier has presented at the AIHA convention, taught the university and OSHA Institute classes, had peer-reviewed publications and professional journals. He still consults in chemical plants and petroleum refineries under his company, Safety Compliance Advisors. Thank you so much for joining us. I'm going to hand over the presentation to Rich. Thank you for being here, Rich.
Good morning. Good morning. Thank you, Berkeley, California, University of California, for having me here. Well, I'd like to start this to the title page. This is the only place where you'll see my contacts. And I'm here not to sell, but I'm here to educate. So we see that we're talking about a pyramid approach to implementation. Over the years, walking rubble fields with my staff and trying to figure out a way to task 3 or 4 other industrial hygienists or safety officers are there to help me. I tried to come with good methods to control and delegate and assign parts of the investigation to different staff members, and also construct timelines for them to produce results in their parts of the investigation. As this process proceeded through the course of my career, I started to come to the realization that OSHA chemical process safety, especially the way that the new standard was constructed when it came into play in 1992, more represented a pyramid than the type of a vertical or horizontal strip chart you see in a general superintendent of construction's office. And so I adopted this pyramid construct. And so using that construct, here are the learning objectives for this webinar. Note that we're going to cover the core principles of chemical process safety and operational safety. I'm going to identify operational elements and speak to the intent of OSHA's PSM standard. And the highlight and the real reason I'm here is to describe a structured and stepwise approach for a collaborative employer-employee program implementation. All right, the core principles of chemical process safety. Many in the industry will say they're written in blood. Number one, there's no run to failure. The whole concept is you don't run it till it breaks. Redundancy, that means redundancy in controls, redundancy in sensors, redundancy in people and decision makers having the level of information and training that if one person's not there or is knocked down, there's somebody behind them that can take over the emergency response. So if you have a control that is critical for your process to keep it in confinement or keep it from failing, you better have 2 of those controls if you are going to engineer this thing correctly. Third item is group decision making. Nobody has a better idea. The group decision making is a deliberative process using a structured format. Three M's. That's an explosive and military term that really deals with minimizing the number of people exposed to a hazard, in this case, highly toxic chemicals or high energy chemicals that could explode. Minimizing the amount of those materials in each pile or storage tank or whatever, and minimizing and maximizing the distance between those piles so you can't get sympathetic explosions or releases. If one goes, it's not going to take every other tank in the tank farm. And finally, and this is extremely important, adoption and recognition of generally accepted good engineering practice. Kim Eves will talk about RAGAGEP. This follows RAGAGEP. You'll get the same thing when you go to the formal OSHA classes in this subject matter area. RAGAGEP saves us a few words. Here's the pyramid. Each of these blocks are important, but what's more important is the foundation. And you note that down here on the foundation, the cornerstones, most importantly, it's the one on the right, site analysis. Of second importance is all that chemical info and safety and health stuff that you get and you have to compile and create and put into a library. The block flow diagram is just a shortcut. There's a lot more on the slides about this block, but it has to do with the flow, the reactants, the temperatures, pressures, starting from where the energy and the raw materials come in and going to the shipment of the finished product. Equipment design is all about the equipment in the process and the materials of construction, the codes that led to the selection of the equipment, the age and the care of that equipment. Staff P&I is participation and implementation. This is a plan on how you're going to put it together and how you're going to create a method to involve the staff and inform them. And finally, site analysis. Then we go up, we see contractor / QC, that's selection of the contractor and your quality control program to make sure that you get what you paid for. ERP, shortcut for hazmat word, emergency action and response program. The next three on that level are confined space, lockout, tagout, and hot work. Those formal OSHA standards were all adopted into the language of the PSM standard. Going up another level, human factors analysis. That has to do with span of control, manning, what you can expect out of one human, how much work can you load on one person, having requisite number of people there at any one time, etc. Operational standard operating procedures is right there in the middle. It's the heart of any good PSM program. Well-written, descriptive, operational SOPs are the heart of any good PSM program. Mechanical integrity is standard speak for maintaining the process, preventing the run to failures and loss of containment. MOC is PSM speak for management of change. That's the deliberative management of change. Nobody has a better idea. Nobody has a better shortcut. It's all worked out in a group in a deliberative process before any changes are affected. Training. You can't train if you don't have operational SOPs, but every worker needs to be trained. And we will talk about two levels of training dependent upon that employee's role in the process and his role within the process safety management program. The process hazard analysis is the heart and soul of figuring out what the hazards are, where they exist in the process, the means and methods that have been put into place to control them and to keep the process from running efficiently. Finally, after you have your analysis, up here I put incidents, investigations, and audits, only because you can't have any of those other things until you've done your hazard analysis. And finally, the capstone is your process pre-startup safety review. You have to do that, which is basically an audit that all these other blocks are in place before you introduce any energetic materials or hazardous chemicals into your process. Okay, let's go to the block of bottom right. Chemical process site analysis. This is all about your site, who your neighbors are, what's going on around you, what the rails and roads are. Please, good location of plants means they've got more than one way in and out. That if you're not getting stuff by pipeline, that you have rails to deliver a lot of these energetic goods. The topography, geology, landscape, and weather. In northern Nevada, we're surrounded by desert. A lot of our plants are out in our desert, but the desert dries out and subject to wildfires. So that's what I mean about topology. Geology, is it built on a swamp, subject to flooding? The landscape, is it on a hillside? What happens if you locate the storage tanks above the plant and there's a leak or an earthquake and all that stuff flows down into your plant? And finally, your weather. Do you get hurricanes? Do you get floods? Do you get tornadoes? Neighbors and your first responders. Do you want your plant located next to a compressed gas liquefaction plant? I don't think so. And how close are your first responders? What are their capabilities? What can they do for you? When can they get there? These are things that you need to know and need to be considered before you locate your plant. Interplant factors really revolve around the 3 M's. You want to keep the high energy stuff far enough apart that you don't get any sympathetic releases or explosions, and you don't locate permanently occupied buildings next to the high energy materials, and that you have adequate exits, roads, and access within the process units. Now, why is that? Fire departments love to be involved. They love to tell you how big their equipment is, what their turning radiuses are, and how much room they're going to need if you expect them to set up and try to respond and help you within your plant in an emergency. And finally, the last thing on this slide is the siting of emergency response equipment. Don't put all your eggs in one basket. You could have a release that compromises one location of your equipment or the only location of your equipment, if that's the case. So put all your emergency response equipment in 2 different spots, duplicate sets. You're going to need them if you're going to try to respond within the plant. Process, the next block is the chemical information and safety health information. That's the other cornerstone. And here we're talking about the stuff you get on STSs, but a lot of this stuff you won't get on STSs. And if you can't find the data or you haven't been able to find them in chemical textbooks, you have to determine them yourself. And this goes for the raw materials, the chemical intermediates, and the finished products. You can't build this program without knowing all of these factors. If you don't know them, you'll have to develop them in a laboratory, then pay close attention to them when you scale up from laboratory scale to pilot plant to full-scale production. And especially when you scale up to full scale production, the thermal and chemical stability data that you generate in your pilot plant will determine how large you can scale up. Cooling reactive chemicals is a science and an art. And keeping these materials from inadvertent mixing really goes to the command and control devices you have within your system, as well as preventing reverse flow. And we must consider also the effects of some of the chemicals and cleaning agents used in maintenance activities. The technology and technical information, that's the block flow diagram. We're still in the middle of the pyramid. The block flow diagram is extremely important. Each node, starting from where your energy comes in, your raw materials receiving, all the way through final production, load out, and pick up by vendors, is a node. And within those nodes, you build your safety program, your general industry safety program, as well as your process safety program. You train within the block, and you use those blocks as your nodes in your process hazard analysis. And note that all that other information that was in there certainly wouldn't fit in that one little block there in the introductory pyramid. So your PIDs, your wiring, your classification zones, your industry codes and consensus standards, the consequences of deviation, your upper and lower limits for all the constants, temperature, pressure, and flows, your inventories, your chemistry, and your history. Now, the history is the history of these processes. If it's a brand new history and a brand new process chemistry, well, that's why you work it up in a laboratory, you build a pilot plant and see how it works at the first level of scale up, and you create your own. But for most chemical processes, there's a long history there. You need all of this information in your library. Contractor selection and evaluation. Here, we're up now at the second level. You have to have information on the contractor's safety record. You want to know how good they are, because you need to get what you paid for. You have to ensure that the contractor complies with all established work, practice, hazard control programs, and communication to their staff and yours. You want to control every worker and every vehicle into the covered process. Security in today's world is very important. You don't want a bad actor to get into your plant for nefarious purposes, to create havoc, to drive down your stock price, or a terrorist event. Quality control. How are you going to assure that? Do you have the engineering staff that can babysit these contractors that you've selected? If not, you're going to have to hire a third-party engineering firm. But the problem there becomes the quality of those gentlemen and the track record they have. You don't want to have and end up with a staff of third semester, third-year engineering students that allow substandard construction. And an aside, we had a perfect example of that at the mid part of the first decade of this century down in Las Vegas at the City Center, where that's exactly what happened. And these young engineering students were watching the work from an engineering standpoint for a third-party firm. And by the time they got to 40 stories, the concrete work was so substandard that the elevator shaft was more than a half foot off at 40 stories. That building had to be demolished. Many billions of dollars of lawsuits are still unresolved. So that's really important that there is a bona fide method to assure that you get what you paid for. The problems that could come from poor construction might not show up for 3 to 5 years after you accept this new plan from your contractors and your and construction managers and general contractors. You could have failures of concrete. You can have pipe hangers fail. You could have connectors fail. Electrical burnout. There's so many things that contractors in big jobs do to cut corners and save money. Copper's expensive. Hangers for conduit and piping are expensive. I've seen it before. They will go substandard on what's required because they're going to put in 1,000 of these hangers. And guess what happens? The hanger fails 3 to 5 years later because he finally can't bear the weight and either pulls out of the concrete or straightens out and allows pipes to fall. And the last point on this slide is the safety performance of all contract workers has to be documented. Okay. Emergency action and response plan. So let's go back and look at the beginning pyramid again. So here we go. To help you guys get where we're at, we've covered the bottom. We're right here now at emergency action and response. And here you need a written plan that includes systems of detection. These are your sensors, your control room gadgets, your hazard alert communication system. Is the computer going to alert the staff in the control room and then they have to alert the workers, or the workers are going to get an automatic alarm? Or are they all wearing personal sensors that tell them when there's been a release? Your evacuation plan and where the rally areas are. Your staff response to releases of hazardous chemicals have to follow OSHA's hazmat standard 1920Q, or California OSHA's equivalent. If you're going to have workers try to control the release, you have to meet the training requirements and the continual training of these people and the equipping with breathing air, protective clothing, and have adequate numbers on the staff to attempt to identify and control and capture and clean up these releases. Sounds like a good idea to have this kind of team, but it's expensive and consumes lots of man hours to do it right. But why do you want to do it right? When you call 911 and tell them you've had a release, you're going to get the police, you're going to get the news media, and oh, by the way, your local OSHA office. High probability they're going to show up. So it's up to the owner of the plant to see the value of doing this right and having a team that you've trained up to these requirements. If you got a fire brigade, and why do you need a fire brigade? If you expect your workers to use more than 2 10 ABC extinguishers on an incipient fire, then you're in fire brigade territory. And you have to meet the fire brigade standards and train and equip and have numbers to where you can have legal responses that equal what your fire department does. This is where I include windsocks, because windsocks, you need more than one. A release or a fire could cover up the windsock, the one windsock from somebody's viewpoint, and they might go to a rally point that is compromised by chemicals or smoke or both that are coming from this fire or release. So to have more than one windsock, everybody on the plant can then determine what is the upwind windsock, and they'll go to that rally point. Confined space, lockout, tagout, and hot work, they're all adopted by reference. These are complicated standards, but they're all things that a PSM facility has to comply with and have the ability to create the permits, to have the same permits posted in the operations center, as well as a worker bulletin board. And another great place to put them is in a bulletin board at the exit to the lunchroom or training room, so that workers can be constantly reminded what are the current hot work, confined space, and lockout and process breaking permits that are in use at that moment. And these permits need to be have step-by-step descriptive instruction on them to describe who's doing the work and where and what's in play. They're going to have the response team, or they're going to double block, blind, and bleed for the process line breaking, or they're going to have a fire watch posted where they do the hot work. This information needs to be communicated. It needs to be posted, and another copy of all of these documents will be needed to be put in this year's binder in your library that we created there on the bottom line of the pyramid. Finally, I urge all plant owners and operators to color code your, use the standard chemical colors for the chemicals within the process, and the accepted labeling for all process components. And that includes breaker boxes, switches, valves. What you put on your process components out in the field's got to match what's on your PIDs. If not, you're going to have confusion. Your SOPs aren't going to work right either for you. This is important. And it helps your inspector and makes him feel good. He likes to see that you've gone through this extra step. Human factors analysis. This has been one of the big issues within the enforcement community for many years in chemical plants. You know what we hate to see? We hate to see the junior operator present on the graveyard shift. Him alone, maybe a security guard at the gate, and that's it. There's not enough people to deal with a response. There's not enough people to go out and do a brief, what they call do your rounds, where critical plant parts of the plant are walked at night as well as during the day. So one person in that control room is not enough. One person at the security shed, not enough. Suppose somebody tries to drive on site in the middle of the night, says he needs a big delivery. You got to ensure that that bill of lading matches something in your computer. You got to have a spot to park that driver and his material while you do look it up. And you need somebody watching that driver to make sure that he doesn't try to ram through your gate and get into your plant. Operator span and control and methods of interplant and between shift communication are extremely important. I've dealt with several catastrophic events where that was a factor in colossal releases, fires and explosions, and multiple fatalities resulted. This is a true event because there was a restriction on overtime. And a group came to the control room and said, we couldn't finish putting in that valve. And when we did our first check, we saw that we put that air actuated valve in backwards, and on is off and off is on. You need to make sure every operator knows that, and then get the next shift maintenance staff to go out there and fix it. And guess what? That communication broke down. It wasn't in the shift log. The operator that was given that message had to go home sick, and a fire broke out. And when they thought they turned the unit off, they actually turned it back on. And when the fire brigade responded, an hour later, it blew up and killed 4 people. And you have to make sure your staffing is adequate to meet confined space and emergency duties. Not only the span of control, but also if you're going to respond to these emergency response issues, you have to have the 2 in, 2 out and the equipment to get these guys out safely. Mechanical integrity. This is the heart of no run till failure. You can't do it. NorCal had a recent example of this in the last 5 years, to where they did run till failure. And inspection SOPs found the problem, but management said, we can't shut it down right now. Ended up with colossal releases and colossal impact in the local community. So mechanical integrity includes inspection, testing, and servicing, all equal the recognized and generally accepted good engineering practices. You create a service log for each individual item. Now, piping runs, for valving, for sensors, your control room instrumentation and controls, everything that it has an individual ID, that has its own label, should also have a service and inspection record. And you don't want these to all be in one location. Have electronic records off-site, and have other records available for the staff in plant to immediately access. And it's okay to have some grease smears on these records, because that shows they're being used. But if something happened, you don't want myself and other investigators and your plant staff to have go and to search the grounds of the plant downwind to see what kind of paper piled up in a downwind corner on the chain link barbed wire fence, and look for the service record, or look for a hot work permit that was involved with that incident that day. Your replacement parts must equal the specified and original equipment. The original equipment and parts are not available. You have to go through the MOC process to validate the new replacement. And here's MOC. That's my lead. This is nobody's got a better idea. Any change has to be managed. And here, boilerplate helps. You create a structured process that is multiple people. Your senior worker for the node, your safety person, your representative of the engineering staff of the plant, and a designated senior operator that's on the shift that day, all must be involved. And you see the types of things that require a management of change. You change anything. You even change the maintenance chemicals. You change the shift. You change the staffing on the shift. These all require MOCs. Numerous events I've done over the years were caused because they changed things and they didn't think through the changes. Oh, we're going to lay off the lab on the graveyard shift. Well, what did that lab do? It took moisture samples of a chemical that's highly corrosive once it's contaminated by water. And that chemical sample were still sitting in the lab after 100 tons of liquefied chlorine was released 2 days later, because a day later, because the graveyard shift, who used to take 4 samples a shift, didn't get their samples, and the pH meter failed, and the operators were so poorly staffed that they started to shut the plant down, but they couldn't fully shut down everything until the release started. And then once that happened, things snowballed. So here's what your MOCs have to address. And I want to say that some of this can be thought out prior by the engineers, the technical basis, but the safety staff and the workers needed to input on safety and health considerations, and the time required, and how we're going to notify and retrain before we restart. This collaborative decision-making process has to be communicated to engineers, the safety and health staff, and the workers and their representatives. And when you finish that, before you put any materials in the process, you do a pre-startup safety review. It's imperative. Okay. The SOPs and training. These have to be clear and concise, step-by-step guidance. Validate them or certify, in the language of the standard, by manual walk down annually. And that's where you're looking at the SOP and its description that valve number V105 is what's in the SOP, as well as what you see in the field. It contains safety and health warnings and requirements that for this operation you need X, Y, and Z safety equipment. And oh, by the way, don't turn off valve V104 next to it. And the training for the workers is 2-tiered. And I say 2-tiered, this is training for PSM. Their hazard, all the other stuff, the hazard communications, this safety and health, all of that is the same for everybody. But as far as PSM's concerned, those senior node workers within your block flow, your process block flow diagrams, those senior workers that are part of your management change team and your PHA team, they need that extra level of training. And once you've got that training, then you have to document comprehension. It's here I want to say that when something happens, there's a tendency for workers not to report near misses and minor events. They're afraid of that corrective action. A lot of times, the first thing of that corrective action in many plants I've been in is they're sent out for a drug test. You're not going to get information about these minor events. They'll hope nobody reports them. They'll let this problem go on, this failure of either the process or of operational education is gone. It goes uncorrected. So don't make this a punitive process. The corrective action is that if somebody goofs up, the supervisor and the worker retrain, and then the supervisor documents that the employee understands what he did wrong, so he won't do it again. The hazard analysis, the PHA, This is the heart of what do we need to keep this thing contained, to keep the beast under control. And the method must be appropriate for the complexity of the process. If you have a real simple linear process, a checklist style evaluation might be okay. But if you're a big, complex, full-blown refinery, you can't get away with something that's just a simple yes-no checklist. And its purpose is to identify, evaluate, and control hazards in the process. I'm going back to where you made that change where you ended up with a big release, where they only had one pH meter to find that corrosivity change in the process stream. If you've got something that critical, a PHA will identify that you need two of them. So if they both fail, you know you're in a world of trouble and it's time to press the e-stop and start shutting this thing down. And the PHA will include information from your library, the previous incidents, and what is predicted with a catastrophic failure of your engineering controls and loss of containment. It will evaluate your early detection by engineering sensors. Do you have enough? Are you going to find these failures? It'll look at your siting and your human factors consequence. Do you need to put sensors at your perimeter? You need to have a line to the school a half a mile away downwind. Let's hope that's not the case, but I've been in places where that's exactly what the situation was. The participation, workers from each process block. These are the senior workers that I talked about earlier in that two-tier training. You should have a couple workers from each process block. Why? Because you don't want the process to shut down if one of them is out sick or taking his kid to the doctor. You can continue the PHA process. It's deliberative, it's structured, and there are people, engineers, groups of engineers that do nothing but this. If you have a complex process, you need to use a complex method, and nothing will help you better than using one of these consulting engineers that this is what they do full time. I've been through this in one or two plants that allow me to sit in under the process, and it was very impressive to see how these process hazard analysis consultants facilitated it, helped develop it, helped keep it moving, and also suggested from their group experience the types of extra controls and layers of protection that were needed. And finally, you have to have performance. You have to track your resolutions. You can't restart your system until every formal resolution mentioned on the PHA has been resolved. And if you aren't able to resolve it, you better have some pretty good engineering documentation and explanations as why you can't resolve it. The budget is not a good reason. We got to keep her going. Let's just use some sticky tape and some sealant and a couple extra wraps is not a resolution. And you have to repeat this process every 5 years. If you wait until the 4th year in a big plant to start up your revalidation of the PHA, you might not make it. Something you should start planning for by the 3rd year and make sure that you got everything in place, that when you start this at the beginning of your 5th year, you've got your vendor set up for your process hazard analysis consultant already selected. You've got the workers trained and ready to go. You can start this process, complete it, and get your resolutions in place for the time of your next plan shutdown. Incident investigation. That's our next block. Now we're getting, to the top of that pyramid. Here the criteria is worker injuries, near misses, process releases of chemicals with catastrophic potential. Well, what is a release with of catastrophic potential? As a compliance officer, I was taught that any chemical release from the process that could injure a worker had catastrophic potential. Your timing. And you have to initiate it within 48 hours of the event. There's a requirement that the team is structured. And others, people who were there, people in that block again from the process block flow analysis, as well as the workers that were involved. And here's the descriptors of the event. And the findings have to be communicated. And the resolutions and corrective action have to be documented with a system to properly resolve all findings. Now, you get one that's that bad, you're shut down. And before you can restart, you got to do the capstone. Here we are. We're at the pre-startup safety review. This is the capstone. Now, if I was a compliance officer and I'm with my staff, I would say this is citation status. But for the operator, you have to do the pre-startup safety review. Here, that's prior to introduction or reintroduction or restart of the hazardous chemicals. You have to do your MOCs. You have to change your process information. That goes to your library. You might have to change your SOPs. So you got a new SOP with a new authorization. And all that's gone through the MOC. Your PHA changes and the findings are resolved, and all requisite staff, that means your staff and any exposed contractors, have all been retrained in the changes that occurred during this or because of this pre-startup safety review. So now I want to go back to the very beginning of my pyramid and talk about what makes a good program and what makes a bad, and how, again, we can implement this program. Each of these blocks can be personally assigned. You put a name, you put initials. Pardon me, that was the presidential alert. You put their names, initials, and the people that are involved in evaluating each of these blocks. Then use these horizontal lines as your timeline as to when you expect the first report, second report. You can kick these out to the side. So there you can track the flow, track the response of people, and how well they're taking care of their extra assignments. If things start to drag, you can see that then you can add extra people. And then when you get to these bigger, more complex issues up here and further up, it's going to take multiple people on the human factors analysis. There are specialists that do this, but truthfully, everybody wants to cram 10 pounds in a 5-pound sack. And sometimes you need to hear it from an outside specialist that that's what you've done, and there's no way you can expect this kind of performance and this much work from this many people. undermanning is been a key factor in many famous events. So now you get an idea how you can use this to track and assign the flow of your implementation and evaluation of your program. You can use this also as part of your PSSR. I mean, that could be a checklist in simple plans, but these things are on your checklist, and the requisite things that were in these blocks become part of your checklist. The same thing for investigations and audits. So you see how this pyramid adds value. Now, what makes a good program and what doesn't? I'll give you an example of one of the best programs and the best places I've ever walked in. Their operational SOPs, they assigned 2 employees from other areas of the plant to run down an operational SOP. So they went into an area that they weren't familiar of, but not with each other, but separately or together. And they walked down these SOPs, and with not being familiar or having a supervisor at their elbow, they were able to understand and execute the SOP if required. So that was impressive. It also allows you to do your certification, annual certification that's required, and it shows you're building this really trained cadre of senior workers that as they move through your organization in plant, that they can step in and become that knowledgeable employee in more than one process block flow for some of these analysis that require, when you have these structured meetings, like management of change, the factors analysis, or the audits, or the investigations, you've built up group knowledge, and you've documented the group knowledge, and it's continuing education. And there's flow of information up and down the pyramid. And let's say this is the top level management, and these are the guys that get dirty in maintenance down at the bottom. That's a good program. That's a well-implemented program. And that impresses any auditor that comes on site. And with that, I'm going to surrender to anybody that's got a question. Thank you for your attention.
Wonderful. Thank you so much. Yes, we do have a couple of questions that have come in so far. And as a reminder, if anyone has another question, you feel free to enter it into the Q&A or chat box. Our first question is, how do organizations staff themselves to have an effective PSM?
Okay. Can you hear me now?
Mm-hmm.
Okay. Well, again, you heard me talk about human factors analysis. And I can just say over and over again, companies are bought and you get a new company in, and we're going to become lean and mean. Well, wait a minute. This plant operated without an incident for the last 20 years, just like they were operating. And so one way is you start with what you got. And if you're struggling and don't have the staff to do this, then you need to add talent. And they have to realize that. And here's the downside. I've issued $1 million penalties in the course of my career for catastrophic PSM related events. And I was only the tip of the iceberg of what followed from the communities and the plaintiff's bar. And so when they say, how do you staff it? You say you staff it and if you need adequately, so you can meet the requirements of the standard, you can continue to operate, and you can bring up the knowledge level of your staff, because you will have turnover, and you always have to predict needs, versus productivity versus profitability. And you're not profitable if you're shut down. You're not profitable if you're shut down and you're in court. You're not profitable if you're being swarmed by inspectors. And now the question, okay, so we got another one?
Yes, we do. Thank you. Do reports generated by the workers' compensation process get referred to the safety management team for evaluation and corrective actions?
Absolutely, within the organization. Now, in my early days, Nevada had a one-way state, and our OSHA was under the insurance company, so we got everything. We saw every single workers' comp thing, and it was really informative. But now we have the concept of competition is going to reduce prices. So yes, that becomes part of your incident report. So yes, and then that incident report has to be shared, like I previously mentioned, within the organization and within the reps, within if they're a union shop, or within the blocks that were involved in the event, and also become part of the record of the performance of that plant. That's part of your yearbook for that year in your library. So I'm ready for the next one.
Excellent. Thank you so much. And yes, we are going to be sharing these slides. I'll be sending everyone who participated today an email, and that'll have a link to the slides for this presentation, and they'll be shared with you as a PDF. And another question we have is, have OSHA issued PSM-related citations, and can you provide an example?
Well, yes. When Sierra Chemical blew up, that was over $1 million. OSHA, Cal OSHA recently issued their record fine in their history against a Richmond, California oil refinery, and the majority of those citations were PSM related. And so yes, it happens. I was working in an oil refinery fire and explosion in California in 1988 when Cal OSHA was shut down by the governor due to a funding argument. And that's when our rocket fuel plant in Southern Nevada blew up. And I had to leave that inspection and go start another one down in Las Vegas. I was 9 weeks before I got home. So yeah, I think these happen, and they're complicated. The big ones take a lot of time, and they suck time, but it's much better to help an employer prevent such an event than it is to come and walk through a rubble field and stub your toe on something that I don't want to go any further to talk about, because it once was a person.
Oh my goodness, yeah. I think we might have time for one more question. California implemented a new comprehensive PSM regulation in October 2017 that contains 9 new elements in addition to the original 15. Do you have a sense of how this will affect PSM practice in California versus other states?
Well, I know that a lot of that was in relationship to that event I just mentioned, from a refinery event, and its impact on the community. And California was able to get in there and fill some holes that we've long recognized in the national standard. And I hope that all of these standards and the way they're promulgated through basically a political process with the stakeholders and then politicians and the effects of lobbying. California there, I think, is really showing its leadership, and I hope that the state of Washington has kind of upped their game. They're one of the more progressive state plans. I'll tell you that the state of Nevada, we are just a little too small. We have some nasty plants, but changing what we have takes the legislature. But I will say that when our rocket fuel plant blew up, we created specific Nevada regulations about the storage and the manufacture of rocket fuel. And we did the same thing with explosives. So it has happened in other states when they've had significant events, but it's usually a reactive process, not a proactive. And so that's really the answer. California's established what they believe is best practice, which was also in some cases, not all of it was, but of this big event that shocked everyone. So yes, it's going to impact other states. People will usually move only after they've been kicked. That's the problem.
Wonderful. Well, thank you so much for joining us, to our presenter, Rich, and also to everyone who joined us online today. COEH does have a monthly webinar series that takes place on the first Wednesday of each month at 10:30 a.m. Next month, on Wednesday, Wednesday, November 7th, we are honored to welcome Logan Van Engelhoven, who's going to present on the evaluation of an adjustable support shoulder exoskeleton. Details about our webinars and other upcoming events can be found on our website, coeh.berkeley.edu. And thank you again for everyone to join us today. I hope you have a wonderful rest of the day.